Welcome to this introduction to probability. By understanding probability, you can understand how to calculate the probability of you getting hit by a car as you cross the road today. Or maybe you could also calculate the percentage of your answer being right, even if you only guessed it during an exam. So let's imagine, first of all, that you have a dice. And let's say this is a fair dice. When we say that something is a fair dice, we mean that this dice is a perfect cube in a way. If you throw it onto a space or a certain surface, it's going to land on any face, and the probability of that happening is the same. It's not like it's a little bit slanted, so it's more likely to, land on one more than three, right? If your dice maker is not that good at its job, then maybe that's the case. But when we say that there is a fair dice, that means that all of them have the same percentage. You can never guess what it's going to be. Now, the event is basically the set of possible outcomes from an experiment. So what we talk about in an experiment is we're basically just carrying out some action that has more than one probability as an outcome. For instance, if you throw the dice, this actually has 6 possible outcomes. You could get 1, you could get 2, you could get 3, you could get 4, 5, you get the point. You could also get 6. So this is an experiment, throwing a fair dice, because you can get all of these different outcomes. Now, the set of possible outcomes from an experiment is what we call the event. For example, the event of getting 1, we can say that is A, for example. So A actually has a probability of 1 out of 6. Why is that so? It's because there are 6 possible outcomes for this dice. And all of them have the exact same probability of happening. So the fact that we talk about this in 1 out of 6, maybe it's easier for you to comprehend if we convert this into percentages. And that gives us a nice answer of 17%, almost there. So 17%, if you translate that into a fraction form, then you get 1 out of 6. Now you can present your probability in both ways, right? Since they both mean the same thing. But it's more, I would say, it's more common to present it in this fractional matter. So how many times can you get 1? Well, there's only one in here. If you had a dice where both of the faces were all labeled 1, then you would have 2 of the 1 outcomes. Then it would make the results different, right? Then the results would be 2 out of 6, which would be 33%. But you get the point, which is that the event of getting 1 is basically denoted as A, and the probability of A happening is 17% or 1 out of 6. What about the event of getting an even number? Even number in here is 2, 4, and 6. So let's just put this back as 2. 2, 4, and 6. That is 3 out of 6 possible outcomes. That will give us 3 out of 6, which is 50%. This event is denoted as B, and the probability of B happening is 50%. In the same way, the event of getting an odd number, 1, 3, and 5, is also 50%, and this is C, event C. Now that we have gotten this event underway, events are really nothing. It's just making this long sentence into one alphabet so that you can use it in further mathematical calculations. But continuing on, let's talk about unions. What happens if we say that we want to find out the event of either one of both events happening? For example, I want to say that what is the probability that you're going to have A happen or B happen? That we represent as A, U, B. U, union, I think it's pretty obvious. And what this means is that the possible outcomes that you want is you can either get 1, even number, 2, 4, 6. So you have 4 possible outcomes, which means that if you randomly throw a dice, this fair dice right here, then the probability of AUB happening, either A or B happening, is 4 out of 6. And that would give us 67%. So that's what union is. Now, intersections are a little bit different, which is that they both have to happen. Now, what this means is that if you throw this dice, you not only expect to get A to happen, but you expect it to somehow also fulfill C as well. What does that mean? Well, what is A and C? It means that you have to get A, but you also have to satisfy the requirements of C. You need to get a 1, and you also need to get an odd number at the same time. There's only one number that satisfies it, and it's, well, number 1, because 1 is an odd number, right? So that is, you only have 1, and the probability of that happening is 1 out of 6, which is 17%. Now, what about A and B? Nothing suits that, because this means that there has to be a certain outcome that not only satisfies this, the event of getting 1, but also satisfies getting an even number. 1 isn't an even number, so there's nothing that satisfies this sort of relationship. And that's when we put these as answers. So we have this one right here, or this. Now these we call null sets or empty sets, which means that there's just no value or there's no expectation. To put things a little clearly, maybe you might have learned about some Venn diagrams in the past. And when we have a union, let's say this is A, right? Oh, this is B. Let's say this is B. This is C. C. And then that is A. This makes a lot of sense to me. B has 2, 4, and 6 inside. A has 1. C has 3 and 5 and 1. So A is enclosed within C. And so hopefully this makes sense to you. When we put unions together, it means we're adding both of them up. For example, B union C will be 2 plus 4 plus 6 plus 1 plus 3 plus 5, which is basically 1, 3, 5, 2, 6, 4. All of the outcomes possible. Now, what happens if every single outcome is possible? Then the probability of getting B union C is actually 100%. No matter what the outcome is, it's always going to fall into this set. And this we represent as 1. The probability of everything happening is 1. Because, 1 translates to 100%. And so this is how I would imagine it. Intersection is like where do the sets intersect in a way. B and C do not intersect anywhere. There's not a single number between B and C that apply to both of them. And this is why B intersection C is also a null set. So this is a Venn diagram that if you don't understand what the question is trying to tell you, then it would be very useful to draw something like this up. And lastly, we have the complementary. And when something is complementary, it means that it's like the probability of a certain event not happening. What is the probability of me not failing, aka me passing? Or what is the probability of me not getting into university, etc.? So, how we represent the complementaries, we just put this little sign up here, just like a little apostrophe, and we just have to take a look at whether or not they have this little apostrophe over here. Now, A apostrophe means this is the event of A not happening. So the probability of, A not happening is basically 1 minus the probability of A happening. Let's take a look at that. So basically, A was the event of getting 1, right? And that was 1 out of 6. If you threw the dice 6 times, the probability is that you're going to get A in one of them. Now, the probability of the A not happening would be 5 out of 6. Anything other than A. Well, anything other than A, there are 2, 3, 4, 5, 6. Those are 1, 2, 3, 4, 5 other possibilities which lead to this statistic. So basically, when we want to get the probability of A not happening, it's basically just 1 minus the probability of A actually happening, which will give us 100% minus 17%. which would give us 83%. So those are the different ways that we use to describe our sets. So now we're going to take a look at this rather wordy question. And it says, a letter is chosen from the word Cambridge. The events A, B, C, and D are defined as A being that a vowel is chosen. Now a vowel would be A, I, and E, so that's A, I, E. The letter B is chosen. There's one B. A letter in the first half of the alphabet is chosen. And a letter is chosen which only has one letter besides it. This would obviously be C and E. They only have one letter besides each of them. So the question number 1 is to describe the event a complement in words. And so if a vowel isn't chosen, then the only things left are consonants. So the answer would be a consonant is chosen. For question number 2, for A, B, C, and D, write down the outcomes that satisfy it. Well, for A, it's AIE. We've already written this here. For B, that is only B. There's only one B in here. For C, a letter in the first half of the alphabet. So then it becomes essential to write down every single letter in the alphabet. And I know that it is a bit of a hassle. So I think, for probability questions, there are a lot of questions that have to do with words and alphabets, and they talk about what is the probability of this alphabet being chosen, etc. It's good to know certain things about the alphabet. So let's go way back into kindergarten mode. There are actually 26 alphabets altogether in the English language. There are also 5 vowels, A, E, I, O, U, and 21 consonants. And if we can divide this into 13, the half happens right between M and N, to be specific. So I think that's pretty nice because M and N are pretty similar looking, so you just split that into 2. It's like splitting siblings apart, and that's how you separate the alphabets. So a letter in the first half of the alphabet is chosen means all the way from A to M. And you might realize that almost every single letter in Cambridge is in the first half, except for R. R is the only alphabet that is behind that. So which is really cool. So now our answer for the event of C is C-A-M-B, no R, I-D-G-E, Cambridge. And then for D, it is a letter is chosen which has only one letter besides it. We've already explained that this is C and E. So D is C, E. So then they asked us to find the probability of each one happening. Now in Cambridge, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters altogether. So the probability of A happening is 3 out of 9, which obviously is 1 out of 3. The probability of B happening, 1 out of 9. This one is 8 out of 9, all except 1. And this is 2 out of 9. Very easy. And then we have D, which is the list of outcomes satisfying A intersection C. So which outcomes not only satisfy A, but also satisfy C? Vowels that are in the first half of the alphabet, which is A, I, E. All of it, right? Not a single vowel. Only one O, and there's O and U, but O and U aren't in Cambridge. So then we have A, I, E. Write down the probability. Well, this is 3, and we have a total of 9 possibilities, so that would be 3 out of 9, which can be simplified to 1 out of 3. And then this says find the probability of A intersection D, a vowel which only has one letter besides it. That's E, right? C isn't a vowel, so that would be 1 out of 9. And finally, we have find the probability of A union B. So vowels and B, which is A, I, E, and B, which is 4 out of 9. So this is how to solve a very simple question that involves knowing what unions, intersections, complements, all of these things, and like events actually mean. So that's around it for this video on probability and an introduction to it. I hope that it helped, and do make sure to check out my other videos that I will be posting on statistics as well. Thank you for watching.